This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hi, this is Priyanka Raghavan for Software Engineering Radio. The guest, Andy Powell, and me work for the same organization, Maersk. Hi, everyone. This is Priyanka Raghavan for Software Engineering Radio, and today we have an exciting topic to explore. Lessons learned from a major cyber attack. And for that, please welcome my guest, Andy Powell. Andy is the Chief Information Security Officer of A.P. Moller - Maersk, the world's largest shipping conglomerate. He's accountable for all aspects of information security and cybersecurity. And prior to joining Maersk, Andy was with Capgemini as the head of cybersecurity. And before that, he used to be engineering officer and then, went on to serve as the CISO for the UK Royal Air Force. He's also the head of cyber defense operations for the UK Ministry of Defense. Welcome to the show, Andy. We're just really glad to have you.
Priyanka, many, many thanks. Yeah, I'm always a bit worried with introductions like that. It makes me feel very old.
Okay. So, of course, my first question to you before we actually go on to the attack which hit Maersk is, could you introduce the audience to Maersk and tell us a little bit about what they do and also about the technology that is used?
So, yeah, A.P. Moller - Maersk is, many people would have seen the Maersk logo on the side of ISO containers going around. We move 20% of the world trade. We are the biggest container company in the world, approximately 750 vessels, which we operate. We also operate within 70 plus ports and terminals around the globe, some of which we own, some of which we're partners in. We also have quite a significant warehouse capability as well for onward transmission of cargo. But really, the most important thing is that we also move 33% of the world's bananas. 1 in 3 of the bananas that you eat was moved by Maersk. So that's always quite an interesting fact I always use when I work with that. I think the main thing is that Maersk operates in 120 plus countries globally, 80,000 plus employees. And clearly, given our critical role in world trade, we are a significant capability and also a significant target. As I'm sure we'll cover very, very shortly.
In terms of technology, I guess you have like a lot of these IoT devices on your ships and vessels and also the terminals? Or?
Yeah, so today, so if we compare today to where we were even 3 years ago, the attack itself, and we'll come on to that, as I'm sure we will in a few questions.
Yeah.
But today, yes, we have a significant, if you can imagine, we have a very significant IT capability around running our business. So we use quite a significant range of technologies from SAP to microservice API type technologies to run our IT. And that runs a quite significant range of capabilities. But also on the OT or operational technology side, we clearly have a significant range of OT capability. And we're instrumenting a lot of that at the moment with IoT networks. Those IoT networks clearly are utilizing cloud technology as well. And we have to protect and provide protection across those networks. And if you can imagine, those OT networks are on our vessels. They're on any of our cranes, and we have cranes in our terminals. Each of those has an OT device on board to control the actual crane itself, right down to the fact that a number of our ports are fully automated. In a couple of locations like Rotterdam, we have a fully automated terminal. And all of those, of course, have OT devices. So a significant technology.
Right, and a huge attack surface, as you say. So, yeah.
Raise a very, very good point. Of course, the attack surface itself has grown exponentially in the last 3 years. Even 3 years ago, for two reasons. One is our digital footprint. We're now operating a vast range of digital services. Of course, the new frontiers we'll discuss of those is the client given identity credentials to access services through the digital platforms. That represents a massive increase in our attack surface. The OT side, of course, is the same challenge with the massive expansion of IoT to monitor and instrument a lot of the OT network. That in itself has increased our attack surface really, really significantly.
Okay, so obviously now we have to get to the chunk of what we want to talk about, which is the attack. And I remember reading this article on Wired when the attack happened, and it said the untold story of NotPetya, the most devastating cyber attack in history. That sounds scary. So could you tell us what happened on that day? Yeah.
I think the most important thing is never believe what you read in the press. Okay? I mean, I wasn't at Maersk at the time. I was at Capital. Was supporting 70 plus of my clients at the time who did get hit by NotPetya. So I have quite a lot of experience in dealing with it. And clearly, as I came into Maersk 6 months after the attack, I was able to sort of fully understand through the analysis and forensics that we carried out what had happened. But let's go back to, and also let's destroy some of the misconceptions that came out of the Wired article, which actually was incorrect in a number of ways. I think the most thing was that Maersk was very transparent throughout the attack. We unlike many companies who were hit at the time, and even those who've been hit since, we were very open, both with our clients and customers, but also with our partners, our technology partners in particular. We involved them, we were very open with them, and that was an important lesson we'll come on to. But let's go back to the day in question, that June day in 2017, when basically what had happened is the attack itself was sown 6 months before it actually happened. And for many who read the press, it was very clear that the route of entry was well planned. So if those who don't know what it was, what it says on the tin, it wasn't Petya. In other words, it was not a ransomware attack. It was a cyber weapon designed by a nation state to cause disruption, significant disruption. Its target was Ukraine. And their aim was to disrupt the Ukrainian tax system and government system, and also during a holiday period that was due to occur in June in Ukraine. And that weapon was launched for that very single reason. And the weapon itself looks like a ransomware. In reality, it was not. And it was the way they used it was a piece of software called Medox, which was the Ukrainian tax software. And this is a lesson for all of us, by the way, for all of us who use tax software to send our tax returns in. It's worth knowing this is third-party software. And for many of your listeners, this is a salutary lesson that all software can be targeted. And it doesn't mean you have to go directly into the software that a company is using. You can use third-party software and get your malware into that. And then, of course, the company who wants to use that software uploads it into their network through a third party. And this is what happened. The Medox software, which we were using to submit our tax returns to the Ukrainian government, like many other Western national companies, that software was basically got at 6 months before by the nation state in question, who basically got the malware through an employee of the Medox. Okay. An individual basically placed the malware into a software upgrade, and that software upgrade went in place in June 2017. It uploaded the NotPetya malware. And that then infected many multinational companies, including Maersk, who were operating in Ukraine. And within about 7 minutes to an hour, the damage was done globally. So your audience understand how this malware operates. Nation-state weapons like this don't hang around. Once they're activated, they're they move very quickly. And they move quickly, they move horizontally, they move across networks. And in this case, there were 4 elements to the malware weapon which operated, and this is widely publicized. A couple of those elements were things that maybe could have been stopped if you'd had the latest software upgrades, the latest patches in Windows and the Windows OS. But most companies don't. Most companies are operating a version of Windows that's maybe one behind or not. Most companies at the time were not operating Windows 10, which Windows 10 would have prevented about 80% of this, but unfortunately the 20% that got through couldn't have been stopped because it was aimed at some underlying infrastructure within Microsoft software. And it was that was exploited by the weapon, and that allowed the weapon to move so rapidly across people's networks, including our own. So really, by way of background, it was not a ransomware. It looked like ransomware. It asked for a Bitcoin ransom to pay to release the data. But in reality, very little Bitcoin was ever retrieved or paid. What the weapon did was bring people's networks down. What it did, very simply, was obfuscate what were known as the Microsoft tables. So the tables that many people are aware of that operate your system through Active Directory, DNS servers, particularly the DNS servers. That was basically what they got at, and basically what prevented people's networks from operating. So in an hour, the damage was done. In Maersk's case, it took us 2 to 3 days to get our Active Directory capability running again. If you're aware of the story, probably many have heard of this. All our online backup was also got at by the malware. So the weapon itself, to take out our existing network, it was able to attack our online backups.
Backup as well. Oh my God. Okay.
We basically were, like many companies globally, reliance on online backup. That was taken down. And the weapon targeted our Active Directory nodes significantly, which meant that at the time, within a day or two, we thought, that's it. We have no Active Directory nodes. They've all been taken out. We have no backups because they've been taken down. We can't restart the network because without image on an Active Directory, it was going to be impossible to restart the network. And so basically, we were pretty close to saying, that's it. We can't go much further. Fortunately for us, in Lagos, in Nigeria, there had been a power outage just as the attack occurred, which had meant that the Active Directory node in Lagos was not online at the time. And so we had a complete copy of an Active Directory node in Lagos. And that was put on a first-class seat on an aircraft and flown to the UK, probably the most well-traveled and well-looked-after server that's ever been. And that server arrived in Maidenhead, and it allowed us to replicate the Active Directory from it so that we could basically replicate that to all the AD nodes that we built. But really, if I go back one, the damage that had been done was significant. We're talking about 40,000 plus endpoints destroyed, 1,000 servers taken down, 1,000 plus applications were taken down. You know, we had no telephone because all our telephone was IP based through the network.
Right. So just to reiterate, it's something like more than some 40,000 endpoints. Your telephones were down. 1,000 plus applications were down. Wow. How long did you recover from all of this?
So the basic recovery period was in 3 phases, really. The first 3 to 4 days was building, if you like, the central core again. We had to rebuild the central core of the network through the AD nodes. And then we had to then, if you like, replicate that by buying effectively all the laptops we could find. Start the network. So we bought most of the laptops in the UK, in India and elsewhere. And we then had to replicate what we had built from Maidenhead out into the various regions. That took us between 9 days to 2 weeks. It took us that sort of length of time to get our core network and processes back up and running again. And we wouldn't have been able to do that, to be honest, without the help of our partners at the time. So we had IBM as our main network partner who was superb, leaning in to help us. We had Microsoft, who did a great job helping us as well. So we wouldn't have been able to do it at that time, at that scale, without involving our partners, plus also the patience of our customers. Just for your listeners, all our ISO containers. So one of our EEE vessels moves 19,000 24 ISO containers per ship. Each ship has contents to customers. All of that on our computer. We don't have the computer. We don't know what's inside each container. We have no record.
Right.
So in many cases, these containers had to be opened so we can know what was inside them, who the consignment was for. And that level of manual intervention into processes took most of it because we had to work out where our key loads were, particularly our refrigerated containers, and we had to ensure they were prioritized for our clients. Many of our clients were really keen to get their cargo. Again, a lesson for your clients, software rules the world, but when the software doesn't work, you have to revert to manual processes, and that's very, very painful in this model.
Right. Obviously, we'll have to now, talk about this recovery process and what you learned from that. So, for example, now this kind of thing that you're talking about, this NotPetya, between the state-sponsored attack. I mean, how do companies actually go ahead and, sort of model for that or, try to take those threats into consideration?
I think you've asked a really great question, Priyanka, because there are probably three groups of threats that most modern big companies like Maersk face today. The most obvious and prevalent threat, about 80% of our threat, comes from organized crime. So organized criminality have basically got their hands on some quite advanced cyber weapons and some quite advanced malware. And their intent is to basically steal money. I mean, organized crime is about making money from crime. Their main aim is to either steal or provide ransomware to try and get, extort money from targets and their victims. So most of those weapons are the ones that we clearly plan to try and prevent, because clearly we're not about to pay out money to these folks. We don't. So what we do is we built our protection around that sort of 80% threat, if that makes sense. As I mentioned, there are two other threats that we face today. The other threat I've just talked about was nation state. Nation state weapons are really in two types. There are the disruptive type weapons, which, NotPetya was. They're used by states against their enemies to disrupt their economies or to disrupt them. We, Maersk ourselves, probably wouldn't be targeted by those, as we weren't in NotPetya. We were a collateral victim of somebody else's weapon, if that makes sense. And that can happen anytime. We have to be wary of that. So I'll explain how we do that in a second. And the third threat is from what we call hacktivists. There's Extinction Rebellion and others who basically use denial of service type attacks to try and bring down companies like Maersk and others who they believe, causing global problems. And so we have to be ready for those level of attacks. Now, those three groups of threats need different treatment. So like many companies, what we do is we design to protect ourselves against the most prevalent threats. And we also build a combination of protection, or proactive protection, and reactive measures. So to go back to my point, we have offline backup now. Backup processes where we can use Excel and other type capabilities to replicate systems that might be disrupted. So if the weapon gets through, and clearly some of these nation state weapons could be very, very difficult to stop. And at the time, very few people could have stopped NotPetya. In fact, only governments probably would have been able to stop NotPetya type malware. And for companies like us to try and stop it would be prohibitively expensive and difficult. So we have to design measures to recover much more quickly. So would it take 9 days to recover from a NotPetya type attack in the future? No, we could do it much, much more quickly. But because we've designed recovery measures to do that. What we have built proactive measures to stop most of the organized crime attacks for good reason. Those protective measures try and stop them at the front door.
Right.
And so that's how we've reacted. We've looked at the range of threats, and then we've built processes around handling that risk.
So there's also this concept of what you call red teaming that security teams talk about. So we are predominantly a software engineering audience, but could you tell the audience a little bit about what red teaming is and, how can that prepare for these kind of attacks?
And in fact, this is a good one for your audience, actually, because they have a role to play in the red teaming approach. So like most companies today, we've built a cyber threat capability within the company, the ability to evaluate threats and, if you like, test ourselves. And self-testing is really quite important for many companies. In the old days, they used to call it penetration testing, which is basically where you had teams trying to get in. I used to run penetration testing teams when I was at Capgemini. And the idea of the team was that their aim was to get into a company's network. Often, 9 times out of 10, we didn't need to hack into the network. We just sent somebody through the front door reception, and they would often find a password written on somebody's desk. And to be honest, why would you spend a lot of money and time trying to hack in if actually you could just go and steal somebody's login credentials? And so, that's one issue. The second is, the exploitation of vulnerabilities in the network. And that's coming on to the point about red teaming. There are vulnerabilities in your network that you often don't believe you could have. And afraid a lot of the causes are what we call backdoors or, software programming errors. And what we tend to uncover is vulnerabilities are often self-created. It's just poor software design. Many of your audience will be aware of the sorts of SQL type injection attacks. The SQL injection is very simply somebody poorly designing the field in a form such that it can be exploited and it can bring down a database very, very easily if you don't put the right limiters on that particular form. That's just poor design. One of the key things is these red teams that we hire in often, their sole job is to go and look for those vulnerabilities and try and exploit them if they can. They're not going to use hacking algorithms, of supercomputers, to be honest. They're going to go and look for backdoors that have been left by software engineers and others. They're going to go and look for poor software design, and they're going to exploit it. What we tend to do is use the red teams to try and think laterally as well. They'll go and look in places that we might not have thought of. For example, are macros, which I hate, by the way, which are used a lot. People design macros to make their jobs easier. But what does a macro represent? It's a piece of software that's been designed to automate a role your task. People use them all over the place to sort of link applications, link processes together. They don't document them. They don't tell us what they've done. They don't tell us where they are. And so we tend to use our red teams to go in and look for those pieces of, quote, software that have been designed to put in to make life easier, but have not been documented. So again, a bit of a call to the audience, document software. Tell us where it is and what it's doing, because then we can stop it being attacked. But the red teams are there to exploit it. They're there to find ways. So we hire them because they think like attackers. They don't think like us. The reality is you've got to find what we call white hat hackers. They're good people whose sole job it is to come and find holes and gaps in them. And that's a powerful method for us.
In this show, we've also talked about things like secure by design and, starting security a little early in the development life cycle. So I'm sure you guys are doing it at Maersk, but is there any thoughts you have on, does it make sense to do this early? Is there a way to measure success?
Yes, there is. And there are a number of ways of doing it. So the one thing I've learned in life is there's no one single solution to a problem. It generally needs multiple solutions applied. And it's the same here. It's if we just simply look at the software design in itself, the software development life cycle, the old SDLC process, which I say old, we're now in the development type cycles that people are using, but we still get a lot of conventional SDLC. We've now clearly got much more dev processes developing. Those processes are exploitable, if executed poorly. And so there's a number of things we provide. And there's probably 4 layers that we look at today, which I'm sure the audience will many of them will be experienced with. We've created a Secure by Design hub where we provide solutions to those 4 issues. The first is, where do I go to get approved code that I can reuse that I know is security checked and cleared already, so I don't have to do it myself. So, we create secure code that they can download and reuse. How much we can reuse that we know is secure, that's good. And it's the same with secure APIs, for instance. It's great to go to a secure API library and you've got an API that's already been checked and cleared. What that does is it doesn't replicate properly in the network. So that's the first solution. The second is what we call patterns. Good software engineer, the first thing you're looking for is somebody give me a pattern to operate. A good pattern. And we will build secure patterns for them as well. So they'll provide those secure patterns in the SPD hub. The idea is they can go and get those secure patterns and use them to build the code. And those are approved security patterns as well that they can reuse. And then thirdly is testing tools that they can self-test. What I hate, absolutely loathe, is the development process stopping and calling in a security person to come in testing for them. Why would we do that? Why don't we get the developers to test their own code, as they do anyway, a security tool alongside the normal tools they use for testing, so that the testing process includes security testing and software guys can operate with it. And that's the issue for us. The problem is, as many of your audience will know, one tool can't fix all the software we've got. There's different forms of software that you've got to provide testing for, like SAP type software testing, API and microservices testing, so more conventional code testing. All of them need different tools. And again, we can provide those tools in the Secure by Design hub. They can be downloaded and used by the developers. It's a really good piece. And then the fourth bit is what I call penetration testing. Again, why don't we have self-contracts that are already in place for the developer just to get in a third party to do a bit of testing of their code as they go with penetration testing, so that those backdoors I talked about are looked at as they develop the modules, rather than then build the whole thing and then penetration test it afterwards. I'd rather do penetration testing as we go. And then that way, when you launch to production, so they're the 4 key things that we're desperately trying to get in place today. If we can get all that up and running, like many companies, it eases the whole process. And also stops security people being the bad people. We're the bad people. The developers see us as the people who are going to come along, a roadblock in their way. I don't want to be the bad person putting a roadblock in the way. I want to be the good person who's helping ensure there's no roadblocks.
Yeah, that's well said. Yeah, because most developers think of, security as well as QA, which I think right now is, it's changing in our agile way of working. People who are, adding impediments to the job. So, so that's a good thing to say. So we did a show on DevSecOps like back in 2017, and that was like what you're talking about, like, trying to incorporate security into the development life cycle. Can you talk us through a little bit about that? Your experience at Maersk, how's it been, or, when previously your organizations, how's that worked?
Yeah, but as I mentioned already, Frank, the problem with companies like Maersk and others is that we have a legacy landscape to sustain. Many of your listeners will know, sitting in most organizations, you'll have a range of different types of code, traditional mainframe-based applications. Many companies still run them. Existing sort of multi-standard sort of monolithic built applications that you've just added to over the years in a non-modular way. Then you've got your modern dev type, evolutionary feature-based type development, which again is great. And then you've got your SAP solutions, which come preloaded, and then you add modules to it, etc. So, just imagine that landscape. And then just the IoT issue that you and I talked about earlier.
Yes.
You've got little bits of code operating in the OT system, and the monitoring some of the IoT networks. And again, that is exploitable type code.
Right.
So that is a landscape that a company like Maersk and many others sort of face today. Many of your audience will be familiar with that. So we have to develop solutions for each of those different groups. One approach. We still do a lot of traditional code testing in our monolithic applications. We still do a lot of a simple, standard approach you would see in many places, because you have to, and your experience as well, I'm sure in your area, is that older applications need to be, as I said, need to be fed and watered. And then, of course, you've got your dev processes. We've talked about what we need in place for that. But then you've got your challenges of SAP, which, of course, is quite a complicated core. And then trying to understand how you test into the core of that is a challenge. And then finally, you've got your IoT space, which is not well regulated. I'll give you an example. Some of the controllers that we uncovered are Windows XP.
Wow. Okay.
Most of your audience will be sat there going, really? Don't even start me on the 3.1 stuff we've uncovered. We have uncovered sort of software OS standards that are variable in the OT space. So if you can imagine software base to start your testing from, deal with the legacy landscape means you've got to be smart. You've got to do it in different ways for different areas. And to your audience who are sort of growing up in the dev world, most companies are not startups with digital development as their main area. A lot of companies like ours have that legacy landscape. And it's important that people are trained and prepared to operate in those different areas. So they're the sorts of lessons and challenges we're facing today. It's exciting. I'd love to be a young developer today coming into that sort of environment. Every day would be a different challenge, I think.
We had an episode a few weeks back on mobile security testing. And that was also, like the kind of different OSs that are coming out for, cell phones is also, you need to support all of that. So I can just imagine how it must be at your company. Obviously, now we're in this pandemic and this work from home situation and things like that. And then I was reading this article about Google where, right now what they do is like they've, just done away with VPNs for all their employees. So just to sort of test their, security. It's a zero trust network. So obviously I need to ask you as a CISO, what's your views on a zero trust network? Would you go the Google way at some point?
It's an interesting debate. I've joined it in a number of forums. I think it depends a lot on the risk appetite in your company. Different companies have different risk appetites. Different companies have different risk landscapes. So if you're a bank, are you going to operate that sort of open network? Probably not, for a number of reasons. If you're a government organization, you'll probably have a similar sort of level of risk appetite.
Right.
Some have a better risk appetite than others. I think risk appetite is what determines how you want to operate. The second point is, what's the hostile threat to you? Who is the likely group who's going to come after you? Now, home working has been a really good example. Most companies like ourselves have seen a rapid increase in phishing type attacks. The bad folks know we're working from home, and therefore people working from home don't take the same care that you would in the office. It's a pretty standard thing. How many of you have used your mobile phone, personal applications on your mobile phone to maybe send a document because you can't get your network working at home? suddenly say, oh, I'll just send it off my iPhone or send it off my personal computer. And before you know it, what you've just done is you've just moved official documents across a largely unprotected personal network. So I'm afraid zero trust requires lots of education, training, and awareness. It requires a degree of baked-in security and an assurance that that baked-in security is there in the products you're using. Very many products that we use are not as safe as people think they are. A good example is Zoom. And until halfway through the pandemic, people didn't realize just how poorly Zoom was. As a tool, it was using processes that were storing private information in an open cloud environment. These are the sorts of things you uncover. You can do zero trust in it if you come to a world where the elements that you're using are secure. The zero trust and trust-based networks are about accepting the fact that somebody offers you something that is good. And I don't trust a developer in another company, no offense, until I've tested it. And yes, there's a big overhead because we're not trusting each other, because we don't build standards, share and use open processes. And yes, do we move? I mean, it's a great debate a number of years ago about Linux. And many of your audience will have been in and would have gone, hey, that's the way ahead. We all shared the code, we did the code together. It made it much more secure than the stuff that's developed behind closed doors. We made it secure because we all worked on it to make it secure. Absolutely. But then what happened is Linux then got packaged to be sold. And what then happens, people created their bespoke versions of Linux, none of which was then open and visible to others. And the minute you don't make things open is the minute you've lost trust. So, long-winded answer to an excellent question, but we don't live in a world that is perfect. And because we have to put in place some checks and balances. And home working has shown that those checks and balances are still needed. So we, like many companies, operate a VPN-based network. We've downloaded significant endpoint security for our home workers. We've helped them with their network security in their own homes because we know their Wi-Fi security has got to be improved. We've done all of that because I'm afraid we're living.
Yeah, because you know the consequences of something going wrong. So yeah, that's also there, right?
But that mustn't create overhead.
Right, of course.
Can't make it difficult for users because I'm sure most of your audience know the minute you make it difficult for users, what do?
They don't use it, right?
The next thing you know, they're using Zoom on their own home computer and they're talking about work and they're passing documents using Zoom because the bad company has banned Zoom. We don't want that. We've got to find ways of embracing the tools they need to want to use, but make them secure so that they can use them properly. So get that balance. It's very important.
It's amazing how much we're in sync, because the question I was going to ask you next was, in terms of designing, there's always a play between security and usability, right? If you really make something too secure, essentially there's at a point where you can't even enter the application, then your application is gone, right? Whatever you're designing, the success of it is how usable it is. So the question is a little bit long-winded in the sense that one of the aspects is of, looking at usability and, looking at statistics of how user behavior is, and then designing your system. Is that something that's also being done with, of course, security in mind?
It's a great question, because I think this is important for your listeners as well, because, software engineers have got to think, how do I want this to be used? And when they're designing what they're designing, their code, their features, their product, they've got to think, how do I want this to be used? Put yourself in the user's shoes coming in. How do they want to access data? And how do you do today? When you go on Amazon to buy something, you want them to present you with a bunch of recently purchased products because you might want to rebuy it. You want them to easily provide you with a list of similar products you might be interested in because you might be interested in them. So there's a lot of what we call analytics, behavior. And you've seen it in modern platforms today. They jump ahead of you. They use data as a means to provide what you want. And what that's meant is that user expectations, your audience know, are very high. They don't want to have to hunt for stuff and look for stuff easily. So when we design security, we have to think exactly the same way. Multi-factor authentication is a good example. If you go to your bank today, most banks use multi-factor as they should. You'll do a transaction, you'll get a they'll send you an independent message on your phone with a code. That code has to be entered back into your computer, having you logged into the system. So you've got multi-factor. If they make that process too difficult, you can't get access to the services. And people will say, I don't want to use that company. They've made it too difficult for me to get in. I'll go and use somebody who's much easier. And the problem is with the company that doesn't use multi-factors, that they're probably exposed to greater threat and your stuff is at greater risk. So you've got to make the multi-factor journey in that case much simpler and easy to use. Okay? And I get really frustrated because I live in a place with bad mobile coverage. So if they send me a code on my mobile, I may not get the code because my mobile is not picking up the code and I can't get into the service. You've got to allow for that in your design. So they've designed it so it automatically calls my home phone landline, which immediately means I know there's a backup. So you've got to design these journeys, these multi-factor journeys or these security journeys, so that you don't scare people away. And when you scare people away, they go and use services which are poor, that are not well protected. And that's what the bad guys are hoping you'll do. They're all, a good example is PayPal. No, it's PayPal, but I'm afraid, PayPal's still catching up in its security journey. Is it as protected as your bank? Probably not. And people attempt to use these third-party payment apps and these third-party payment systems because they're much easier seemingly to use. But in reality, they're maybe not as well protected. But we've got to think about making the user journey through the security piece much easier. Many of your audience will be saying, why do we use passwords? Because I have to remember the password, I have to write it down. Or why don't we just use biometrics? So I can use my iris, my computer camera. Make that happen. Why can't you make that easier for me? And the answer is could, but unfortunately, the technology isn't quite there yet. We would like to do it that way. We'd like to use multi-factor with biometrics. We'd like to find ways and means of making that journey much easier because we know that passwords are easily exploitable. 99% of passwords are insecure. They're very poor.
Right.
Most bad guys know how to break password chains very, very easily. So we've got to find a better way of doing that, for example. But we have to find a way of doing that that's easy for the user. So they don't have to find a biometric device to put their thumbprint on, or it doesn't get a bit of grease on it and it doesn't work and they can't get into the application. So we've got to find ways and means of solving those engineering problems.
So do you actually employ people who go and talk to your clients to see how to make a better sort of journey in terms of security? Is that what you do in the companies?
On the vendors side, yes, because I'm selling cyber solutions to companies like that. So I wanted some selling points, some unique selling points that make this. And a good example for many of your audiences, I'll go back to the digital frontier. What is the new frontier of people's networks, companies' networks? It's not firewalls and network security anymore. It's identity and access management.
Right, exactly. Yeah.
So we need to go and talk to the vendors who are providing IDAM solutions and say, how do we make them customer friendly? So how does a customer coming into my website wanting to access a service and book a container and get data on that container, how do I make that journey easy? How do I ensure that I do the identity and access for them in a seamless way? How do I secure the data using PKI and other standards that they're sending to me and back? How do I ensure that their data in my network is secured and easy to access? How do I walk through that customer journey? And we do, yes, use companies to help us do that. There are lots of third-party companies out there who will walk you through the journey of a customer and say, this is how a customer will react. And it's a bit like red teaming, but from a client perspective. If that makes sense.
Right. Okay.
Using those sorts of methodologies.
Okay. I was also curious in terms of nowadays, you talked about analytics. You have a lot of this data that I'm sure you're collecting. You use that for also in terms of, studying threats. Is that this a specific kind of, do you look at that kind of?
We use third parties to help us there.
Okay.
So there are third-party companies out there who provide data which use to help us analyze the threat environment and the user environment. Clearly, the data we use is fully cleared through privacy laws where we use data. But the data we often get from third-party companies is analyzed through third-party tools that help us understand patterns of behavior threat patterns, etc. Patterns is king, just so you're aware. In the world we live in, you've got to look at patterns of behavior, patterns of use. You've got to look for changes in those patterns, because that often is an indicator of something that might not quite be right. So for instance, if a customer's behavior in logging into the network changes, that indicates if they normally log in the morning and the afternoon to book containers and check their container moves, and then suddenly you're seeing a range of logins through the day significantly increase, that gives you a bit of an indicator that maybe either something's happened on the client side or somebody is using the client access to get into your network. And those are the sorts of signs you've got to look for. Most companies are looking for those signs, unusual patterns of behavior, unusual routines, because that then helps us rapidly, proactively, then go and look for threats.
So I guess what you're talking about is like you're looking for these patterns, but are you like having these fancy, like what they show in these Hollywood movies, like a really cool operating center where, you have these many screens where you're looking at, hey, that container looks odd behavior. Is that what's that? Tell us a window into that. That would be interesting.
I think companies like ourselves are no different to many other companies. We have a Triple C, as it's called, which is our command and control center. We also have a global cyber defense center, and they are multi-screened. When our people are in them, they look very and we're able to access them remotely. So all the capability has just been accessed remotely at the moment, but in the same way, it's very effective. But yes, in those screens, so the Triple C, for instance, is monitoring application behaviors all the time. They're looking at how applications have been accessed. They're looking at how those applications are operating. And we're able to collect a lot of data on application use, a lot of data on network, on how things are operating. And that allows us to create, pictures. You're right, yeah, it's a bit Hollywood-like. I wish I had the sort of money to create those Hollywood super centers. But in reality, we've got a pretty good capability that allows us to have good eyes on lots of those statistics, lots of those use patterns. And my analysts, my tier 3 and tier 2 analysts, are very smart folks. They can immediately spot something unusual in the collection of those logs. And we do that like most security companies. We collect security logs and we analyze those logs using software. Software allows us to spot patterns in how the people are accessing various applications. We look at the logs. And if there's something wrong, as I mentioned to you, my analysts go, hold on, that doesn't look right. And then we go and focus on what might be happening around that. Lots of software, but I just want to say something to your audience. Capability isn't just software. Capability is software, people, and process. If you have people, process, and a tool, that's capability. And every combination, that 3 combination. Software is an element, is a tool to help the process, to help the people. Okay, it is itself a capability. Does that make sense? And therefore, when your software engineers are designing their code, they need to think people and process. They need to think how it works together. And that's what we're looking for all the time. I'm not looking at software. I'm looking at how the software is being used by people to implement processes. And if that doesn't look right, that gives us an indicator that maybe it's been exploited by others.
So a lot of the recovery, of course, you've got your tools, you've got good software practices, good design practices, as we discussed, but a lot also has to do on process. So that is also something that has changed a lot in your...
Yeah, and again, both time process and the operational process. So you need to look at all those processes. So clearly in the design process, we've introduced a beacon system, which allows us to make sure various processes are being executed during the design phase. That's not a spy in the cab looking over the shoulder of the developer. That's there to help the developer, ensure that they use processes during their coding. But we also look in the sustainment of that software that is operated, and we look again using beacons as a means to sort of see how those processes are being worked. And it's important, it's important that people follow a process, and that process gets logged. We know the right process is being followed. We know that's good. So making sure the process is being followed. Good developer will do that. Repeats good process.
So the process and people and technology is what is the key. That's from your recovery perspective. I guess the other thing I wanted to find out was also in terms of, you talked about your pattern, right? Where this secure pattern that you have, that also gets, I guess, improved based every time. Like one of our podcast episodes, we also talked about, machine learning models built for security. And there was this thing that, the machine learning models, they also get hacked. Any thoughts on that? Like, do you have any safeguards for that, or have you thought so far ahead? Or
I mean, most of what I've been talking about, by the way, just to emphasize, this isn't just Maersk, this is a global issue. I wouldn't want your audience to walk away saying Maersk are doing all of these things. Maersk are leading these things. We're doing what most of the industry is doing. All I guess I'm repeating to your audience is the good things that we're seeing and implementing at the moment. But going back to your excellent question, AI is the future. AI for all of us is something we need to embrace. We need to look at AI. And in security, we look at AI from two angles. We look at AI as a way of attacking us. So most of your audience be aware of botnet.
Yeah. Yes.
And how to be subverted to attack and deny capability in the network. And, there's areas where AI is getting really smart. They're using AI to do multi-password breaking. They're trying to hack passwords using AI. So they're using AI tools today against us, in order to try and attack us. On the other side, we're using AI tools to defend us. I'll be honest with you, to do many of the things we have to automate it. I can't take 10 million logs, security logs, and manually go through those logs. I have to have software and AI tools to look for patterns and changes and difficulties. And that software and that pattern behavior software, that AI, is so important. On the security side, we're seeing some great capabilities coming onto the market. IBM Watson's been there a while, looking at security patterns. They're using it in that space. There are many other companies. Microsoft are doing the same with their tooling. So a lot of AI tooling has been developed in the security space. What is the one worry I have? And it's the point you raised. What would I do if I was a bad guy? I wouldn't attack my network. I'd go and attack the tool that I'm using to defend my network, or subvert it, or try and disrupt it. Because if I can disrupt the AI tool they're using, I can launch an attack which might be more successful, if that makes sense. So yes, it goes back to my point about third-party software, where we're all using tools that we built by others. And if I were a bad guy, I would try and get into those third-party supply chains and disrupt. Right. Just going back to the opening question you asked me about the Maersk attack. The Maersk attack wasn't onto a piece of the Maersk software. The Maersk attack was launched through third-party software that we were forced to use, that was provided by another vendor and sustained by another vendor. So we have got to, like all the community, has got to get better at third-party software security testing and evaluation. Right. And back to your point about zero trust network, we can't trust software that other people build until we as a community become a little bit more joined up. Out of the early days of Linux, we're not going to get to that nirvana.
Where I work also, we sort of do that. We do check our third-party open source libraries. Hopefully we'll do that with renewed vigor after this conversation. So I think I'd like to end the show with asking you, I think what you alluded to this, it's only a matter of time before you get hit by any major company, or, small startup could get hit by a cyber attack. So if there were three things that you would, give as advice, could you just, three things that, we should keep in mind?
There are three things that I think every company, and we've done it at Maersk, and it's three simple principles, and we built three target operating models around them. The first principle is risk, and understand the risks to your network. Where are those risks? Where are those vulnerabilities? It comes with visibility. You need visibility. So the first thing is risk allied with visibility. You need to know where stuff is, and then understand what that risk is. The second piece is you need an operational capability immediately to deal with events that occur proactively and reactively. You need to build that sort of capability. So a lot of big companies don't have security operating centers. They don't have what I call the goalkeeper. Football fan, big Liverpool fan. What are the three things you need? You need a goalkeeper. It's pretty essential. And that's what the Security Ops Center provides. You need that goalkeeper who can operate the processes and ensure things can work if they were disrupted. That's the second piece of the jigsaw. And the third piece of the jigsaw is the secure by design piece. Those three pieces of risk, operational capability, secure by design. Get those three things correct in any company in the right balance, and you're actually in a good place.
Okay, that's great. Thank you so much for this conversation, Andy.
Great, thank you.
Yeah, it's been great learning experience. I think quite different from what the other shows we've done because we've looked at a case study. And I hope the listeners enjoy. So I'd just like to sign off and say thank you for listening to everybody. This is Priyanka Raghavan for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.